Yeah, thank you very much.
Thank you
So
so
it's a
much.
pleasure to be here in this session. And back to my youth, where I started as an astronomer, and then I became a lunar mission scientist. I'm going to tell you a bit this little story. But astronomy from the moon is an area where we have done some studies, but also now we are preparing the next phase. So at the same time, I'm going to advertise some of the work of my collaborators that will be presented in different sessions, which is linked also not only with science from the moon, astronomy, but also science of the moon or science on the moon, life science. And this is illustrated by some of this slide where you see what we have deployed in a program called Your Moon Mars. So it was before Earth Moon Mars, where we developed a program to analyze data, to develop instruments, to test them in the field, to go in some habitat, and then do some simulation of what we'll have in the moon base. And we'll see at the end that this has also a link with astronomy and space science you could do from a moon base. So as I mentioned, I started as an astronomer. So I was at European Southern Observatory. When I came back to Europe, I worked at ESA. And so I was doing astronomy. But I organized my first conference on astronomy and space science on the moon was like 30 years ago at COSPA in Washington. And okay, we were describing what we could do with telescopes, radio telescope, infrared, solar, planetary observations. And then we created this International Lunar Exploration Working Group with all science represented, the industry and so on. But because I organized this session on science from the moon, I was labeled a lunar scientist. So right after that, we did also some work on how to protect the lunar environment. And then they were looking for somebody to run the first mission to the moon. So they picked me. And I was then in charge of Smart One, our first ESA mission to the moon. You can see it there. And then this was launched 20 years ago. And we were then alone around the moon at the time. But now we have a beautiful village, orbital village, a fleet all around the moon. We had Kaguya, we had Chang'e 1, then Chang'e 2, and then we had Chandrayaan 1, where actually I was negotiating to put 3 ESA payload on board, as it was mentioned this morning. So indeed, 20 years ago, ESA had a mission at the moon, the first of this millennium. It took us 3 years to build this mission. And then now we had to wait 20 years not to build a mission. So I don't know, something we have to see how we can learn to work a bit faster. But now we have some nice payload which are prepared for future mission. But this is a mission where for 100 million euro, we went to the moon and we brought some instruments. And also we deployed an ion engine. So from the science of the moon, we did some remote sensing, studying so tectonics, cratering, volcanism. Even we surveyed the polar region for the first time. And we even did our own impact, which was observed from Canada, France, Hawaii telescope in 2006. So eventually, we also made a survey of the south polar region of the moon. So this is actually a mosaic that was produced with our camera. You see very interesting area there, which we can use for future exploration, for science, also for emplacing base, for emplacing telescopes as well. Eventually, we also found close to the south pole of the moon, a ridge, we call it the Smart One peak of light, where you have the maximum amount of light even in winter, and which is now one of the sites that is planned for Artemis future mission. So what about signal from the moon then? You saw this impact flash of Smart One. At the same time, we were monitoring from an array of radio observatories from Earth one song of Smart One because we had no fuel left, so we had to do a touchdown. And so you can see some nice from Italy, two sites observed, from Australia, and also from Brazil. And eventually, this is the last signals that we received from the Smart One spacecraft. At the time when the signal died, we got in real time this picture of the impact from Canada, France, Hawaii. So it was quite interesting multi-wavelength observation. So what we did 25 years ago, we created an international lunar exploration working group to coordinate what the different agencies and stakeholders would do. Is a step-by-step precursor orbital mission, robotic village, outpost, and moon base. So what could we do then in the area of astronomy with this roadmap? So as you know, no atmosphere, all wavelengths are accessible, good seismic stability, avoid dust, that's what we have to take care, but a great place to monitor the Earth, the sun, the planets. We even had an interesting idea. You just put a telescope and just let it fix. And then the sky can just gently drift and you could monitor variability. Even you could monitor weak lensing and do a bit what we do with Euclid, but okay, Euclid is better. Do variability studies, deep sky telescope. You can deploy a liquid mirror telescope of 30 meters that will be 10 times deeper than James Webb Space Telescope. Also, you have the coldest areas in the solar system, 40 Kelvin in the permanent shadow region, great for far infrared. And also, you can measure high energy radiation or even particles, X-ray, gamma rays. But you can also use the soil as a Cherenkov detector. And like we use the atmosphere as a Cherenkov detector, but there you could detect particles of 10 to the 20 electron volt. Here's an example of a paper we published about lunar liquid mirror telescope at the moon with Roger Angel and Bora and Pete Warden. And we just had the data from Smart One at the time from the North Pole. So we found the best place where to position it. We developed at the time of Google Lunar X Prize, a small lander, and then we put a telescope on it, and then we tested to teleoperate it from a moon base that we built at ESTEC. And eventually we put it in another country and we teleoperated this telescope as it would be on the moon. And you can see when you will have the telescope on the moon, this is what we obtained with this telescope. You could observe the Earth. The Earth is 4 times bigger and 60 times brighter than the moon, the full moon. But we did this test using a telescope to monitor the moon, but it will be the Earth, but also to monitor the sun, to monitor planet, and also to use, you can use a telescope to monitor a scene where you send a robot, an astronaut, 2 or 5 kilometers distant. You can then spy on the astronauts from Earth. So we organize also a workshop where we put all these people using telescope and instrument. As you know, we have started a robotic village on the moon. 2013, Chang'e 3 landed, deployed a rover, which was short-lived, but then had a telescope, a 20-centimeter telescope in UV that is still in operation after 10 years. So we have a telescope on the moon. Now, what about radio astronomy? We've heard about this beautiful radio telescope and so on. We don't have the Earth ionosphere on the moon, a bit of daylight ionosphere. You have also to take into account the fact that because of interstellar scattering, you don't have an absolute angular resolution, so you have a scaling law here. So if you have 1 megahertz, you have a 22 arc-minute Ponce function. So it's not very good images, but if you go a bit bigger in the 20 megahertz, you can still see, make some nice maps. You have also a time of spreading in time of the signal due also to interstellar medium. And okay, we have heard about the fact that as a function of redshift, this is the signal that you have from for different redshift, and then everything is piling up if you look back in the past. So in this low frequency area, in particular this 21 centimeter band. So we tried to do a demo with some radio telescope. Here we looked at very close sites, looking at the sun, looking at Jupiter, in particular this Jupiter radio burst, eventually a bit of the Milky Way. And we monitored it. So this is the solar spectrum, you know, radio burst with the different time variations. And you could try to monitor the giant planet. Here is an image you could obtain. This was obtained by a probe, which was at Jupiter, a beautiful image, but you could do that with an interferometer from Earth. And we monitor also the IO. And eventually, you can also monitor some galactic sources, also with some of these precursors. So for this, we deployed, you have some factors to take into account, reflection of the regolith and so on. We discussed that. But we deployed a precursor experiment in collaboration with the DLR, Robotic Mechatronics Institute. Okay, we went at Etna, very similar soil. And then we deployed a number of instruments there, in particular an interferometric array of 4 radio telescopes that we deployed last June in 2022, also as a demonstration of what you could do on the moon. We also did some work deploying some instruments using some astronauts. And of course, that would be in preparation for the future, where we'll have also humans that could deploy some of these telescopes. Now, there are many challenges for that. I would just end in advertising some of the posters which are presented. So we are looking some astronauts for 1 week in a moon base. So we are looking for volunteers to look at the poster. One of also our collaborators, Serena, has built a portable moon base. And maybe we are going to bring it on Thursday and Friday evening here. That's a place you can borrow it for 1 month. That's how it looks like. And this is to train researchers. And so you will see possibly it on Friday. And eventually we have also, I'm directing a base on Hawaii, where we are also organizing a field expedition where you can test some of your instruments and your science. So this is with enclosures, Mr. Tetris. And we have recovered. So we have a nice mission control center in Hawaii. And that's how the base looks like. So I want to invite you to come test your instrument, your telescope, your EVA protocol. We have done that for 2 years. We recovered from COVID and from the giant eruption. So we went there again in March. And so now all these field activities, we try to put them, use them for credit on the worldwide Eurospace Hub or Earth Moon Mars Academy, where you can go some training. And so we have now obtained a funding from the European Commission to fund researchers, astronaut field campaign. So if you're interested to join, please come see some of the posters and those presentations. And so beyond the astronomy from the moon, also we realize that training astronauts to use some of these various instruments will be also very synergetic, and we will help also to feed forward the design of real missions that we are going to send. Thank you very much for your patience.